Hello, everyone. I'm Frank, and welcome to episode 17 of Learn How to Sudoku, and where we take very easy variant Sudoku puzzles and break them down in more detail so that you can learn how to Sudoku. Today's very easy puzzle is called Monopoly Rules, and it's by a channel favorite, Gerhard 1963. And here are the rules. Standard Monopoly rules apply. And these are standard Sudoku rules, I think. The digits 1 through 9 appear in every row, column, and box. So the standard Monopoly rules are essentially standard Sudoku rules. Okay? Cages. Digits in cages cannot repeat and must sum to the value shown in the upper left corner of the cage. So that would mean, for example, these three digits must add up to 14. These three digits must add up to 17. These three digits must add up to 19, etc., etc. So a valid example here would be if this were like 2, 5, and 7. Those three digits add up to 14. So that satisfies that cage rule. And these are usually called killer cages. So that's how killer cages work. Little killers. Clues outside the grid are the sum of the digits along the indicated diagonal. Digits may repeat if allowed by other rules. And that's these digits that have an arrow with them, right? So that's saying that these digits on the diagonal add up to 11. These digits along this diagonal must add up to 17. These three digits along this diagonal must add up to 11. These three add up to 21. These 6 that I can get, hopefully, add up to 18, etc., etc. And the digits that do not have an arrow they're a different type of clue, so don't worry about those. But these are called little killer clues. And they sort of similarly act similarly as cages, but again, remember, digits can repeat along the diagonal. And that's how little killers work. Finally, the last rule is skyscrapers. Each cell represents a skyscraper whose height is the digit in that cell. Taller skyscrapers obscure the view of smaller ones. Like if you're like viewing a skyscraper, like say you were viewing like a host of skyscrapers along a line. Each digit is the height of the skyscraper. So if you have a taller skyscraper, it will block all the skyscrapers that are shorter than it that are behind it, right? Clues outside the grid tell how many skyscrapers are visible looking across the row or column from the direction of the clue. So that would mean this 2 means that you see only 2 skyscrapers if you look in this direction, right? So that means you would not be seeing 3. You would have to see 2 skyscrapers. So you would see 1 skyscraper here, and then like another skyscraper behind it. But then then you would not see any other skyscrapers either in between. So there would be anything that's shorter than the first skyscraper, and you would not see anything that's behind that second skyscraper. That leads to various things that you can have. This says that you see 4 of these skyscrapers, and remember, the higher the number, the higher the height, right? And you cannot see a lower number or a lower skyscraper that's beyond if it's lower in height than one of the previous ones that you see, right? So that means you see 4 skyscrapers here. You see 3 skyscrapers along this column going up, and you see 8 skyscrapers if you go this direction, right? Not sure if I can give a good example. Well, okay, so let me try. So for this 2 skyscraper, let's say we had a 5 3, 4, and 9. So, and then, I don't know, 2, 8, 6, 1, 7. This is a valid skyscraper. This is a valid column that satisfies this skyscraper because it sees the 5, but it cannot see the 3 or the 4 because the 5 is blocking it. Then it sees the 9, which is 2 skyscrapers, but it can't see anything beyond that because the 9 blocks all the other skyscrapers in this column. So that's an example of how skyscrapers work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so what's the easiest way? Probably V8. This sees 8 skyscrapers, right? So it must see, and this sees 2 skyscrapers. So we know 9 cannot be the first size skyscraper it sees along the 2, which means that 9 cannot be in this cell here. Because if 9 is the first cell here, it basically only sees that 9. And that would mean that the clue outside would have to be a 1 then. Because it would only see 1 skyscraper. So this can never be 9. Since this can't be 9, this sees 8 skyscrapers. This can't be 9. Where is the 9 in this row? Well, it can't be any of the first 7, because if 9 is one of the first 7, so 9 cannot be here because it can't be 2. So this can't be 9. 9 cannot be any of the first 7 because if it's anywhere in the first 7, once it sees the 9, it can't see any other ones behind it. So if this were 9, it would only see, at most, 7 skyscrapers. Therefore, this cannot be 9. These cannot be 9 for a similar reason. If it sees that, this sees at most 6 skyscrapers. But we know it sees 8 skyscrapers. Therefore, none of these can be 9. Whereas the 9 in row 1, it must be here. So this is a 9. Since this is a 9, this has to be lower than 9. So it sees every single one of the other skyscrapers here. So this must be seen, and this must be seen, right? Well, this could be only... What does that mean? That means this digit must be higher than this digit, which must be higher than this digit, which must be higher than this digit, because it must see 8 again, right? So every single one of these must be increasing. Like a thermometer. So if you have seen other puzzles that I've solved, we've had thermometer rules, right? And this is similar to a thermometer rule. It's because it always has to be continuously increasing up to the 9 because it sees 8 specific skyscrapers. And to see the 8 skyscrapers, it can never have one that's blocked until you get to the 9. Right? Because it must see this one, which must see that one, so therefore this is greater than this is greater than this is greater than this, etc., etc. So this can be at most 8, this is at most 7, this is at most 6, most 5. So if you know my way I usually solve thermometers is I usually get the highest number, go all the way down to the bulb, and this would be the bulb in that case. And then I basically say what are the lowest and the highest for those digits. And then those are the boundaries. So this is 1 or 2, which means this has to be 2 or 3, etc., etc. This is 3 or 4, 4 or 5, 5 or 6, 6 or 7. This must be 7 or 8. Now, these 3 digits add up to 22. So this is 9. So therefore, these 2 digits must add up to 13, which is 22 minus 9. So if you have 2 digits adding up to 13, it could be 4, 9, but we can't have a 9 here. This must be either then 5, 8, or 6, 7. In addition, we have 3 digits in this box along this diagonal, the little killer clues, which must add up to 11. And it must contain a 7 or an 8. Well, the thing is, if it's an 8, that would mean this is 1, 2, and 1, 2. But if you have 3 digits adding up to 7, that must contain 1, 2, and 4 specifically. Because there's no other combination of 3 unique digits in a normal Sudoku that adds up to 7, except 1, 2, and 4. So these have to be 1, 2, and 4, which eliminates 1, 2, and 4 from the rest of the box, because we have a 1, 2, 4 triplet. Therefore, what can this be? It can be 3, 5, 6, 7, or 8. Well, what's the minimum for this diagonal? It has to be 1, 3, and 7, which adds up to exactly 11. Therefore, this must be 1, 3, and 7 exactly then, because those are the only ones that can add up to 11, because that's the minimum. So this is 1, this is 3, this is 7. Now these two add up to, these 3 add up to 22, and these 2 already add up to 16, therefore this is a 6. So these can't be 1. This can't be 3, 6, or, this can't be 3, 6, or 7, and this can't be 3, 6, or 7. And this can no longer be 7, therefore this is 6, 5, 4, 3, and 2, and therefore that's a 1. This 5 means this can't be 5, so this must be 8, and this must be 5. These 3 digits add up to 14, 2 and 3 add up to 5, 14 minus 5 is 9, so therefore this is 9. These 3 digits add up to 18. Minus 3, 18 minus 3 is 15, so therefore these 2 digits must add up to 15, and we cannot have a 9 here. So what are the remaining digits that must be? This must be 7 and 8. So this is 7 and 8. Let's see. In this triplet, or this cage, we have 3 digits adding up to 24. The only digits that work, and they're unique, the only digits that work that way is 7, 8, and 9. Same here, there are 3 digits adding up to 7, as we said in this box. This must be 1, 2, and 4, because otherwise, those are the only 3 unique digits that ever add up to 7. We know these 3 digits add up to 21. Well, can 1 and 2 ever be with those? No, because 2, if you have a 2 here, that would mean we have 2 digits adding up to 21 minus 2, which is 19. 2 unique digits that add up to 19, which is impossible. So therefore, this must be a 4, which means these can't be 4. And that means the 2 remaining digits must add up to 21 minus 4, which is 17. 2 unique digits that add up to 17, there's only one possibility, which is 8 and 9. Let's see. This must see 4 skyscrapers going this way. If there were a 9 in either of these 2 spaces, it does not see any other skyscrapers beyond that. So then it would see only 2 skyscrapers at most, or 3 skyscrapers at most, if the 9 were here. Therefore, the 9 cannot be in either of these 2 spots, so we have a 7, 8, 7, 8 pair in box 7. And this is box 7, this is just convention. We label the boxes from top to bottom, and then left to right, because that's the way that Westerners normally read. So it's just a convention that we use so that we can easily communicate to each other what we're doing. So this would be box 1, 2, 3, 4, 5, 6, and now this is 7. So that's why I said in box 7, we have a 7, 8, 7, 8 pair, which eliminates 7 and 8 from the rest of the cells in the box, which makes this a 9. Again, similarly, if this were an 8, that would mean that you can see at most the first cell, the 8, and then a 9 later on in one of these cells. So that would be 3 skyscrapers you could only see. Therefore, this can't be an 8, so this must be 7, and this must be 8. And we know the 9 has to be one of these 3 cells, because this can't be 9, so therefore that's 8, which makes that a 9. This can't be 8 because of this 8, so that makes this a 7, which makes that an 8. The 9 has to be one of these 3 cells. The skyscrapers seen this way are 3. And once it sees the 9, it can't see anything past that. So this must be 9, obviously. And therefore, it sees 2 other skyscrapers here. So this digit must be smaller than this one. Well, what can this be? This can be at most 7 because the 8 is there. So this is at most 7. And therefore, this is at most 6. Well, what else could it be? It can be 3 and 5 because 1, 2, and 4 form a triplet in box 9. And we can't, therefore, the rest of the cells cannot be 1, 2, or 4. So this is 3 or 5. And therefore, this must be 5, 6, or 7 because it cannot have 1, 2, and 4. And it must be greater than 3. So along with the 9, how do these add up to 19? Well, you have 2 digits then that must add up to 10 because 19 minus 9 is 10, and these 2 digits are the leftovers in the cells. 5 can never be with another cell there, and 6 would have to be with 4, but we already have a 4 in the box. So this cannot be 5 or 6. This must be 7, and this must be 3 then. So this cannot be 3. This is 5 or 6. Therefore, what is the last cell? It also must be 5 or 6 because those are the only digits remaining in box 9. Okay. What about these 2 cells? These 2 cells must add up to 17 minus 8, which is 9. So, and it cannot be 1, 8, cannot be 2, 7, it cannot be 3, 6 because we have those all in the box. Therefore, this must be 4 and 5. What's the last remaining digit? This can't be 5 because of this 5, so this is 4. This is 4, which makes that a 5. This can't be 4 because of that 4, so this must be 2, which makes this 4. What's the last remaining digit in box 3? It must be 6. So this can't be 6 anymore, so this is 5, which makes this a 6. Okay, what do we have here? This has 3 digits adding up to 11. Well, we already have 8 as one of the digits, so the remaining 2 digits must add up to 11 minus 8, which is 3. Therefore, it's 1 and 2. Because those are the only 2 unique digits that can ever add up to 3 in a normal Sudoku. And this can't be 1, therefore it must be 2, which makes that a 1. Which means that can't be 1, so it's a 2, which makes that a 1. Here, we have 3 digits adding up to 13, which is the cage. And one of them's 2 already, so the remaining 2 digits must be add up to 13 minus 2, which is 11. Now, if you have digits adding up to 11, two digits adding up to 11, we already can eliminate 2 and 9, because we already have a 9, 3 and 8, because we already have an 8, and 4, 7, because we already have a 7. Therefore, this must be 5 and 6. And 5 cannot be here, so this must be 6, which makes this a 5. What are the last remaining cells in box 7? It must be 3 and 4, but this can't be 4 because of that 4, so this is a 3, and this is a 4. That's 3 in the corner. We celebrate. And these remaining cells are, what, 2, 5, and 9. And they can go in any order. That's fine. What are these remaining cells? It has to be 6, 7, or 9. These remaining cells in this column are 4, 5, and 8. And the remaining cells in this column are 1, 2, and 3. Okay, the remaining cells here are 1, 2, and 8. And the remaining cells here are 3, 7, and 9. This can't be 5 because of this 5. What are the remaining cells here? It's 1, 7, and 8. The remaining cells here are 5, 6, and 9. And the remaining cells here are 2, 3, and 4. Okay. Now, the remaining clues that we have... Okay, actually, we were still missing this one. So this is 1, 7, and 8. This is 3, 4, and 6. This can't be 6 because of this 6. This can't be 4 because of this 4. So what I see now is that the only remaining cells that the only remaining clues that we have not solved are these diagonal little killer clues. And what I usually like to do is I like to figure out what the constraints are, right? So what is, for example, in this one, I see what is the lowest value that can be on this diagonal? Well, it would be 1, 4, and 6, and 1, 2, and 3. What does that add up to? 1, 4, and 6 adds up to 11. 1, 2, and 3 adds up to 6. So 11 plus 6 is 17. So therefore, the minimum amount possible is the amount that we need exactly. So we know then that these have to be the minimum amount then. So this is 1, 4, and 6. This must be 1, 3, and 2 then, because of the way the little killer clue works. Therefore, this can no longer be 3. This must be a 4. This can't be 3, so this must be a 6. This can't be 2. Therefore, it's a 9, which makes that a 5. And these can't be 1. These can't be 6. This can't be 4, 4. And this can't be 1. This can no longer be 1. This can no longer be 2. This can't be 3 and 9, so it must be 7. This can't be 7, and this can't be 7. So let's look along then this diagonal. And what is the minimum there? Well, this could be 2, 5, and 1, which adds up to 8. And this is 3, 1, and 6, which adds up to 10. So 10 plus 8 is 18, which again, so the minimum adds up to the exact total we need. So therefore, the minimum must be that, we know along the diagonal, it must be the minimum specifically. Because we've tried basically decreasing it all the way, and since we can't go any further, you can only go up from there, right? So the minimum then is the restraint, and we know the value is exactly the same as the minimum, so therefore it must be the minimum there. I don't know if it's sort of intuitive to me, so I'm not sure how else to explain that. Well, okay, say you tried to change from the minimum to get some other set of numbers, right? Say you changed this from not the minimum. Say you made this a 2. Well, the problem is, since it's increasing from the minimum, that means it can never be the same value as the value we want, which is the minimum. Does that make sense? I'm not sure if it does. But because it's the minimum, if you try to change one of the digits from the minimum possible of one's already there, that would just increase the value, which would not equal the value that we want then. It would always be higher than the value we want, which therefore means that if you change any of the digits, it would basically not add up to the value that we want anymore, which would break the rule. So that's why you know that if you have a minimum or you have a maximum that adds up to a certain value on the little killer clue, you know that you can't go any further higher for the minimum or lower for the maximum to get that same value along the diagonal. So therefore, you know this is the minimum too. So this is 1, this is 3, this is 1, this is 5, and this is 2. Which means this can't be 1, therefore that makes that an 8 and that a 2. This can't be 3, so this is 9. This can't be 7, so this is 8, which makes that 7. None of these can be 1. None of these can be 2, and none of these can be 5. This can no longer be 6 because of that 6, so this is a 9, which makes that a 6. This can't be 4 because of that 4, so this is a 3, this is a 4. This can't be 3, so this is 2, this is 3. And now we try to figure out where things can be. Well, the 2 has to specifically be here now, because we have already 8 digits placed. Therefore, we know where the 9th one has to be. So this is a 2. What else do we have? I think we have 8 1s, right? Yep, we have 8 1s. Where's the one? Last one has to be placed. It has to be here. Do we have 8 3s? We do have 8 3s, so the last one to be placed in box 5 must be here. 4s. We have 8 4s too, so the last one to be placed is here. 5s. Do we have 8 5? We do not have 8 5s. Okay, so that's not helpful. 6s. We do have 8 6s though. 1 2 3 4 5 6. Yeah. So the last 8 6 to be placed must be here. And then now we can start eliminating things. So this has to be 7 or 8. That's not as helpful. This is 5 and 9 then. This can't be 9, therefore this makes that 5, which makes that 9. That 9 means this can't be 9, so this is 7, which makes that 9. This can't be 7, so it's 8, which makes that 7. This can't be 8, so this is 5, which makes that 8. And now we just complete it. So therefore this is 7, and this is 8. And that's how you solve it. So yeah, I hope I was I hope I was clear. This is actually a very common technique. Anytime you use like little killers or even sometimes like anything that you have addition or yeah, addition usually. You usually try to find what the minimums and the maximums are, and that will constrain the digits that you can have, right? Particularly in this case, um, if you constrain it to the minimum and it equals the value itself, you know that the minimum has to be there, right? It doesn't always work that way. Sometimes it'll just be like 2 or 3 from the minimum. The total value will be 2 or 3 from the minimum, which then leads to degrees of freedom, or what I like to call degrees of freedom. But I guess that's for a future episode. But basically, learning to try to find the minimum maximum values to constrain the values that you can have is very helpful. Anytime you have additions and even multiplications sometimes, um, that's very helpful. Anyways, I hope this solve was helpful for you, and I'll see you next time on Learn How to Sudoku. Take care.